Accuracy mark clear swab plan, right, Chris 100.
This is Talk of the Nation Science Friday. I'm Ira Flato. One of mankind's oldest dreams is to bend Mother Nature to his will. The ancient Greeks were among the first to write about it, describing the hero Odysseus as trapping dangerous winds in a bag to prevent them from spiraling into a storm. Some Native American tribes danced in hopes of releasing water from the sky. Other attempts at modifying the weather have encompassed everything from prayer to cloud seeding. That's why I suppose the popular saying, so many people talk about the weather and no one being able to do something about it. But some scientists are doing more than just talk. They are planning and experimenting with new ideas that sound so radical, so far out that they seem to come right out of the latest science fiction magazine. For example, some scientists hope to give weather modification a high-tech twist with devices that could zap tornadoes from outer space or squelch hurricanes before they hit land and even spark rainstorms over parched farmlands. Well, this hour we'll be talking with these daring thinkers about the practicality of their ideas and whether we will ever own the weather. And if we do, what are the potential consequences and possible unforeseen side effects? So if you have questions or comments about affecting the weather, weather modification, or anything in that general neighborhood, or how scientists plan to modify, give us a call. Our number is 1-800-989-8255, 1-800-989-TALK. And as always, you're welcome to surf over to our website at sciencefriday.com, where we have links to our topics. Let me introduce my guests. Bernard Eastlund is the president of Eastlund Scientific Enterprises Corporation in San Diego, and he joins us today from the studios of member station KBPS in San Diego. Welcome to the program, Dr. Eastlund.
Thank you very much.
Thank you. KERRY EMANUE is a professor of atmospheric science at the Massachusetts Institute of Technology in Cambridge, and he joins us today from his member station studios, WBUR in Boston. Welcome to the program, Dr. EMANUE.
Thank you.
ROELOF BRUINTJES is scientist of Mesoscale and Microscale Meteorology at the National Center for Atmospheric Research in Boulder, Colorado, and he joins us today by phone from Boulder. Welcome to the program, Dr. BRUINTJES.
Thank you very much.
Charles DOSWELL is a senior research scientist at the Cooperative Institute for Mesoscale Meteorological Studies at the University of Oklahoma in Norman. He joins us today by phone from Norman. Welcome to the program, Dr. DOSWELL.
Thank you, Ira.
Let me go through quickly with each one of you and talk about your ideas. First, Ben Eastlund, you have an idea, a plan how to tame tornadoes. Could you give us in a nutshell, what you plan to do there? What might be possible?
The idea is to find the fine structure within the storm that you might be able to affect to prevent the formation of a tornado.
Mm-hmm.
The target that's most likely the best to find is the cold, rainy downdraft. The tornadoes form on a line on a curve between updrafts and downdrafts.
Mm-hmm.
And the energy for rotation is presumed to come from the cold, rainy downdraft. My concept is to use either ground-based or satellite microwave beams to heat that downdraft and disturb its motion, hopefully to prevent the transfer of energy to the vorticity. In other words, the idea is to stop a tornado by an in-depth knowledge of the storm before the energy can be fed to the rotation.
So you sort of zap the tornado, the storm, before the tornado starts with some intense microwave radiation.
Well, I prefer not to use the word zap. The level that has made people fearful. The level.
I was not using it in a derogatory term. But.
Well, the point is though, it's in terms of what you could make with a microwave beam.
Mm-hmm.
This is a mildly heating beam. It's a lot of power, but it's spread over a large area.
Mm-hmm. All right, KERRY EMANUE, you have a plan to suppress hurricanes. Give us your nutshell on that one.
Well, our idea is very simple. In fact, it's very ancient. It goes back almost as far as the Greeks. It's been known for a long time that the source of energy for a hurricane is the evaporation of seawater, and this is in fact why hurricanes rapidly dissipate when they move on shore. That evaporation is cut off. The idea is to spread a substance on the sea surface that curtails the evaporation of seawater. If you could do that, you could presumably reduce the intensity of the winds. So we're looking into that.
And how would you do that? How would you prevent the evaporation?
Well, it's also been known for some time that there are certain types of substances, oils, polymers, generally a class of substances we refer to as molecular monolayers, which if you put them on the surface of the water, spread out and form a very, very thin layer, literally one molecule thick, that at least in benign conditions is known to slow down evaporation. Benjamin Franklin experimented with this. Obviously, he wasn't after curtailing hurricanes. He was just interested in the idea. But he was notable for having taken a teaspoon of olive oil and put it on a lake and watched how that oil spread to cover virtually the entire lake, just one teaspoon. So there's hope that you could treat a large enough area of the sea surface to reduce the evaporation. What remains to be seen is whether this kind of thing would work under the terribly perturbed conditions that one encounters in hurricanes.
Yeah, I'll bet. Dr. ROELOF BRUINTJES, let's talk about weather modification, in this case, cloud seeding. You have experience with cloud seeding.
I have been working basically the past 20 years in this, mostly in terms of rainfall enhancement. This history goes a little bit longer back, and experimentation has been going on for about 40, 50 years in this field. However, oftentimes with mixed results. Lately we have been using new hygroscopic particles dispersed by flares below the clouds and obtained some intriguing results from a statistical sense in both South Africa and Mexico. However, questions arise. Our physical understanding of the processes are incomplete in that regard at this stage.
Because I remember over 20 years ago going to Florida and Coral Gables and watching them seed clouds and not having much good results with it.
Correct. One of the basic principle is that all the water vapor contained in clouds in the liquid on the ice form doesn't come down to the surface, and if we can find means via cloud seeding to change that percentage to bring more down to the surface, this could benefit sort of water resources in general. In terms of usually there are two main pillars in this type of science: statistical results, because we revert to that due to the natural variability in the atmosphere, and then the other is our physical understanding. And oftentimes the statistics and the physical understanding didn't go hand in hand, and also provided for mixed results.
Charles DOSWELL, you've written extensively critiquing weather modification. What do you think of these three ideas?
Well, clearly my role here is that of a skeptic, and I sort of enjoy that role. I certainly don't want to come off as a nattering nabob of negativism, but there are a lot of unanswered questions. I think Professor Emanuel and some of the other gentlemen have talked about some of the questions that pertain to their ideas. And I guess I'd just like to be a little bit more confident that we know what we're doing before we try some of these things.
Are there possible side effects or consequences that that might happen we haven't thought about?
Well, human history is littered with examples of unintended consequences. Yeah. And it's very clear that at times during experimental phases at small scales, some of the unintended consequences were not clear, only to become obvious later. An example, which is perhaps somewhat irrelevant, but nevertheless pertinent in a philosophical way, is DDT. Everybody thought it was a wonder substance when it first came out, and it wasn't until 20, 30 years down the road that we discovered it had a lot of negative side effects. So I'm just arguing on the side of caution.
All right. Before we get into the individual ideas, and we'll do that after the break, what makes you gentlemen think that you could control such huge forces that you're wrestling with? I mean, a hurricane is considered the powerful force on Earth. A tornado is nothing to sneeze at, and getting ringing water out of a cloud is a pretty big feat. I mean, do you think we're at a point in technology that we can actually lasso these big forces of nature? Gentlemen, just jump in there.
Well, I'll say something about that. I mean, the hurricane is a colossal amount of power. In fact, the average power consumption by a modest hurricane is equivalent to that of the worldwide electrical generating capacity. So we are dealing with very, very strong forces. What makes us think so? Well, in my case, I don't think there's any self-delusion going on here. It's a long shot. We know enough about the physics to know what we have to do, and as Dr. DOSWELL suggested, the only thing we can do is to proceed very cautiously, and in my case we're doing some very modest experiments using a wind wave tank in a laboratory, which we might like to talk about later, but I think you proceed step by step and see how far you get.
Well, I'd like to step in on the same issue. This has been Eastlund. I held back on pursuing this idea until I saw a numerical analysis using an advanced code out of the University of Oklahoma by Jeff Trapp. And in that, I could see that technology was improving on simulations to the point where there was some hope that they could be a technology tool that could show us how to do this. And I might just point out about the role played by Dr. DOSWELL. He has helped me see that those codes need a lot of improvement before we can safely predict what is going to happen. And in fact, the last 6 months, I've mainly been focusing on trying to get that technology improved. But the answer to your question is yes. Technology has made many major advances that can help on this.
Dr. BRUINTJES, as you say, the cloud seeding goes back many decades. Anything new now that would make you think you can succeed where you couldn't before?
I do think there are several things new. I think, especially in terms of some of the statistical results we've obtained with the hygroscopic seeding. And then the other aspect is the evidence that is coming out in terms of inadvertent weather modification on clouds, especially from ship tracks and also biomass burning, indicating that clouds are modified even inadvertently to some extent. The other issue is that most of the research in this field was heavily funded until about the early 1980s. Since the early 1980s, very little research funding went into this kind of research. And I think we have developed new tools like remote sensors, numerical modeling capabilities, airborne instrumentation that haven't been brought to this problem at this date, which I think have some new exciting opportunities.
Is there any record of any successful cloud seeding today?
It depends how you define success. I think there is no, from a scientific point of view, we cannot say there is any successful cloud seeding experiment in my view. Success in terms of having intriguing statistical results, yes. Also success that we know we can modify certain processes in clouds, yes. However, a comprehensive program has not been conducted in terms of looking if it is possible to really increase rainfall over a large area.
All right, we're going to take a short break and then take lots of questions on the phone and talk more about each one of your experiments and get into it a little more in detail. So don't go away. I'm talking with KERRY EMANUE, Professor of Atmospheric Sciences at MIT, Dr. ROELOF BRUINTJES, Scientist of Mesoscale and Microscale Meteorology at National Center for Atmospheric Research in Boulder, Charles DOSWELL, Senior Research Scientist at the Cooperative Institute for Mesoscale and Meteorological Studies, University of Oklahoma in Norman, and Dr. Bernard Eastlund, President of Eastlund Scientific Enterprises Corporation in San Diego, California. Don't go away. Lots to talk about weather modification, so take your questions after the break. Stay with us. This is Talk of the Nation Science Friday. I'm Ira Plato. We're talking this hour about weather modification with my guests, KERRY EMANUE of MIT, ROELOF BRUINTJES of the NCAR in Boulder, Chris DOSWELL, University of Oklahoma in Norman, and Bernard Eastlund of Eastlund Scientific in San Diego, California. Of course, that's KPBS in San Diego. Our number, 1-800-989-8255 is our number. Let me ask you, Ben Eastlund, given that there are roughly 1,000 tornadoes, let's say, that rip across the U.S., how do you plan to choose which one? How do you go about making this a practical solution here?
obvious answer is you would stop the worst ones, the force 3s, 4s, 5s. But I have a hunch it would start out a lot like the early days of dialysis. When you had a technology that could only help a few people, then you have a commission or something that will decide in what order and how you take care of the problem. So
you have basically a fleet of satellites that are orbiting the Earth that have microwave power in them that can be beamed to any place? Is that how it works, basically?
The concept, and the European Space Agency had me look into this, is to tie this technology into what's called a solar power satellite. That is designed to transmit solar energy, convert it to microwaves, and convert it to Earth. I would see either a fleet or a few of those in geostationary orbit, and they would be alerted by the weather Doppler radars if something's forming. And believe me, you have to know what you're doing before you do any of this, but they would be alerted, and then they would take care of it and then go back to their main job, which is producing power.
And you think you can get enough power from the satellite system down to a thunderstorm someplace?
Well, the interesting thing is the amount of power I need for the storm is much less than the power slated to be on these types of satellites. They are designed to be truly large generating stations, which here in California, of course, we're very sensitive to the need for some new power approaches. But the amount needed for the thunderstorm modification is smaller than the amount planned for these facilities.
And when you hear about plans with orbiting satellites and microwave downlinks to transfer energy, you immediately think of the Department of Defense being involved here some way, because it sounds like a wonderful thing for military strategists. Does this have any roots in DoD planning at all, or research, or money?
Well, my original work on this general area was funded actually by the Defense Department. The answer is, if you wanted to make something that was harmful, you wouldn't make these kinds of a beam. These are really, as I said before, very mildly heating. Good analogy is at the power level that I ran in the codes that we did at the University of Oklahoma. The beam is just like a police radar beam, and you would know if you're focused on the rain. If you aren't, you can turn it off in less than a second. And an interesting analogy is with an MRI treatment. 1 second of exposure to this beam is equivalent to about 7 seconds in an MRI treatment. They use radio frequency in an MRI, and typically an MRI treatment will be 30 minutes or an hour. So in terms of absolute danger, I'm really talking something that you have to be very cognizant of, and you have to be very careful for safety. But the absolute level I'm talking about is really a mildly heating beam.
1-800-999-8255 is our number. Chuck Doswell, sound pretty benign.
Well, I know he makes it seem that way, and it may well be that in some absolute sense we're not talking about a high concentration of power. Of course, how many MRI beams do you really want to go through in your lifetime? But irrespective of any dangers associated with the beam, and we can debate that endlessly, I think there are probably two fairly important problems that I see. One of them is that tornadoes form very rapidly, and there are a number of very practical problems associated with identifying which storms you're going to subject this to. And I think even if it did prove to be practical, in some sense, to modify storms and prevent tornadoes in the way Mr. Eastlund is describing, there are still yet a number of very large practical hurdles to overcome, not the least of which is the multi-billion-dollar cost of the satellites necessary to make this happen. Furthermore, recent research in tornado genesis suggests that, in fact, warming the downdraft may have exactly the opposite effect desired. There are some indications from recent work done in the field and in various field projects associated with the so-called Vortex project that suggests that, in fact, warm downdrafts are the ones that are most likely to produce tornadoes. So Mr. Eastlund's proposed fix might, in fact, make tornadoes longer and more violent.
Okay. Any reaction, Dr. Eastlund?
Well, let me start with the last comment first. I have been basing my analysis on use of the ARPS code at the Center for Analysis and Prediction of Storms, and the work done so far is just very preliminary work. The comments that Dr. DOSWELL made to me about a year or so ago pointed out to me that the codes do not use microphysics of raindrop size, for example. And I believe the true answer to this question can only be found by really good simulation and really good validation. Mm-hmm. And the type of program I'm working on now is to have that go hand in hand. One can say, oh, it might not work, it might work. Both the analysis and prediction of these storms needs to be greatly improved. And
I certainly can't argue with that.
And that's what I'm starting out to do. And one of my great hopes, if we can ever get Dr. BRUINTJES pointed out, there is no funding available for this in any way. But if we should get it turned on, then I think every bit of knowledge needs to go in to see if there really is fine structure there that we can affect.
KERRY Emanuel, moving on to actually stopping hurricanes from starting by coating the water with some kind of oil and then keeping evaporation down. Has that ever been tried even on a small scale to see if that works?
Apparently it was tried in the old Soviet Union, and we've contacted some scientists who were involved in that project, and we're going to try to look at some of the documents about that, which have been recently declassified, but we don't know about that yet. The approach we're taking is a very cautious one. We're trying to understand whether we can even do this in a laboratory apparatus, that is, whether we can reduce the evaporation from the ocean surface.
All right, 1-800-989-8255. Let me see if I can get a couple of calls in here. We'll come back to our guest. Gail in Portland, Oregon. Hi, Gail.
Hi.
Go ahead.
Well, I'm a person that loves weather. And I guess my question is primarily, just because we can do it, should we do it? One of the things that I haven't heard discussed in this is the experience of human beings as a species to our planet and its weather. As a photographer, I love the magical light of a storm. The empirical experience of weather is something that is hard to even define and how that relates to our lives. I moved to Portland because I love rain. And since it's part of our experience as a species, it's part of our aesthetic and spiritual sense. And in many ways, it humbles us in the sense that the planet is larger than we are. And one of your guests, I believe it was Chuck Goswell, made an excellent point, which is human history is littered with unintentional negative consequences. And what begins with those great intentions, because we've saved lives, etc., we stopped a tornado, but what happens when the technological genie is out of the bottle? And one of your guests used the example of dialysis. And I thought that was a great example to my point in that it's a concern about what begins today as something that is meant to benefit humankind. Tomorrow will be privatized and there will be corporations trying to make money off of it. Like dialysis, there are lots of fingers in the revenue pie. And so I guess I would be interested in your guest comments about that.
Gentlemen?
I'm very sympathetic to that point of view. I characterize myself as kind of a weather nut, and I'm also a photographer. And I guess my experience has been that going out and watching the weather has left me with a sense of joy and wonder, and it sort of makes you naturally kind of an environmentally concerned person almost inevitably. And I have to say that even if the weather that we get isn't always what we want, I'm not sure if we started messing with it that we would end up where we want to be.
Yeah, exactly.
And I'd like to step in on
very
this.
Very concerned about that.
Go ahead.
Could I step in?
Sure, you can.
I'm glad you made the caller made this personal, because if you ask me why I'm doing this or why I'm interested, it began personally. We moved to Houston in 1982, and within a month, our house was hit with a tornado. We were warned it was coming. We were up all night listening. The 12 tornadoes hit that night. One small problem. There are no basements in the houses in Houston. We had nowhere to go. All we could do is sit there and wait. Now, I am just as much for environmentally sound technology. I have a lot of first-hand experience on how technologies can be twisted from what you start doing. But the fact is, if it is possible in the future for people like the people in Houston with no basements to stop a tornado from happening or modify it, I firmly believe it should be done.
Maybe I can step in here also, Rolf BRUINTJES.
Go ahead.
I think I sympathize with what Gail is saying. My personal experience starting this was after I finished my bachelor degree. I had to work on a project like this in South Africa. The thing is, at the moment in the world, more than 34 countries, and even in the U.S., there are more than 46 ongoing operational cloud seeding projects, without a sound scientific base to a large extent, and without a big evaluation component. My work in this regard is trying to understand what is really happening. In addition to that, the other aspect is that the evidence coming now from inadvertent weather modification, biomass burning, pollution, affecting also precipitation processes in clouds. And in terms of those processes, I think we as scientists have a responsibility trying to understand those processes inadvertently and advertently in order to be able to assess what really is happening.
Now, I agree with that completely. In fact, I think that's a wonderful thing to connect, because we're already modifying the weather. We just don't know what we're doing. And without the research that Dr. BRUINTJES is talking about, we'll never be able to make those connections. The operational seeding programs that are going on all over the country, and in fact all over the world, are essentially very badly designed to help us understand the physical processes that they're supposedly exploiting to modify the weather.
Gail, have you been soothed, convinced,
well, Ira,
turned around?
Can I ask one more question?
Sure.
Because another thing that really concerns me, I can imagine a day when, today we talk a lot about a digital divide. I can imagine a day where I'm sitting watching a television, and because we have the money for the technology in this country and in other developed nations, where we were successful in stopping a tornado in Oklahoma, while we also watched simultaneously of one that devastated, say, the Ivory Coast, because they don't have the money for the technology. And it seems what so often begins with the best of intentions in science. And I agree, we absolutely should know and understand weather. We've been trying to do that since we were primitive men with stone tools. And it you know, to understand it is a great thing. To alter it is potentially a revenue-generating machine, which I can see we would have a weather divide in the globe.
To add to all the other divides, add to the other divides we have.
I'm sorry?
To add to the other divides that we have.
Yeah, correct.
All right, Gail, thanks for calling.
Thank you.
We're talking about modifying the weather this hour on Talk of the Nation Science Friday from NPR News. I'm Ira Flato, and let me ask you, Dr. BRUINTJES, are you saying, and maybe you can all talk about this, are you saying that despite what we think we know about how rain forms and is precipitated out of clouds, we really don't understand it enough that we could modify it?
I think in terms of, there are some parts of the whole process that we understand fairly well, and there are some parts of the process that our understanding is weak at this moment. I think especially in terms of, we know we can make small changes, we can create ice crystals in the clouds, we can possibly create smaller droplets, or we could create larger droplets. How this then works with the energy, interacts with the energy in the cloud in terms of producing updrafts, downdrafts, gets into the tornado picture, gets into hurricanes, we do not understand fully. This is one of the major problems also in quantitative precipitation forecasting from thunderstorms and also from other type of cloud systems. So I think in the dynamical sense, we do not have a full understanding because the scales are so varied, from small to larger scales, spatial scales, all influence those processes.
Dr. Eastlund, in terms of radiating a storm cloud before it turns into a tornado, why could you not try that on the ground first, or with maybe if you're using maybe a laser beam, or if you're not using microwaves, from a flying airplane, some sort of military or a test or NASA or some kind of airplane like that, and to see how it would work? Why would you have to go outer space downward first? Sort of proof of concept sort of thing.
Well, most of the concept will be proven with a computer before you try any experiments.
I see.
But one of the points is they come up fast. They can be almost anywhere, and the ability to see one form and then diagnose it, I think, could be better. I'm not against using an airplane or something cheaper, but for example, an important component in the model is the downward velocity of the rain. The present Doppler radar systems measure the horizontal components and then infer the vertical component of the rain velocity from algorithms. With a satellite, you can look down and get a good Doppler measurement. Now, so it's very ideal for determining where the structure of the storm. It's good for diagnosing it and also for validating it. And
it's not quite that easy.
In other words, you can see better.
It's not quite that easy. A satellite doesn't point down vertically. It points at some angle. And so you're still going to have a number of problems diagnosing vertical motion, even if you have an active radar on a satellite. And you still
directly over it.
This horrible problem that a tornado forms what appears to be a non-tornadic storm extremely quickly. We're talking 5 minutes or less.
All right. Well, and I have about less than that to go to a station break. So let me rudely interrupt, and we'll all meet back here right after the station break and talk lots more about weather modification and how difficult that is to do, and whether we want to do it in the first place. So don't go away. We'll be right back after the short break. I'm Ira Plato, and this is Talk of the Nation Science Friday from NPR News. Welcome back to Talk of the Nation Science Friday. I'm Ira Plato. This hour, we're talking about weather modifications with my guests, ROELOF BRUINTJES, scientist of Mesoscale and Microscale Meteorology at the National Center for Atmospheric Research in Boulder, Colorado, Charles DOSWELL, Senior Research Assistant at the Cooperative Institute for Mesoscale Meteorological Studies, University of Oklahoma, Norman, Bernard Eastlund, President of Eastlund Scientific Enterprises in San Diego, California, and KERRY EMANUE Professor of Atmospheric Science at MIT, and you know where that is, in Cambridge, Massachusetts. Our number, 1-800-989-8255. Let's go to Leon in Laramie, Wyoming. Hi, Leon. Go ahead. Leon, are you there? Leon.
Yes, I'm here.
Go ahead.
I was wondering if hurricanes and tornadoes are actually beneficial, stirring up oceans, cleaning out rivers on the coast and things of that nature. I'll take my answer off the air.
All right. KERRY EMANUE, wouldn't you be doing a disservice if we got rid of the hurricanes?
Absolutely. Here we have a situation which is very different from that of tornadoes. If tornadoes do anybody any good, I've never heard of it. But hurricanes apparently are vital to various aspects of the climate system, actually. The caller mentioned the churning up of the upper ocean, and there's been a lot learned about that in the last 10 years or so. Hurricanes are very effective mixers of the upper ocean that actually affects the biology of the ocean, and it may even affect the net poleward heat transport by the ocean. In addition to that, tropical cyclones, especially the weaker ones, actually bring a lot of rainfall to various parts of the world which would suffer if you didn't have them. So when we talk about modifying hurricanes, we are definitely not talking about going after more than a very, very tiny fraction, probably less than 1%, the ones that really threaten populated areas with devastation.
I'd like to add something to what KERRY just said, and that is that although it's difficult to imagine at this point that tornadoes do anybody any good. There is one sort of nagging question that I think bothers me and perhaps some others. If we don't understand what tornadoes are for in the atmosphere, then disrupting them could have those negative consequences we talked about. Kerry quite correctly talked about how hurricanes play an important role, and we understand that role reasonably well. The fact that we don't understand the role played by tornadoes doesn't mean they have none. And if somehow we were to prevent a large number of them, there might be some very negative consequences we know nothing about at this point.
Mm-hmm. Let's take a call from a place they know about tornadoes, Tulsa. Hi, Devin.
Hi, thanks for taking my call, Ira.
Go ahead.
I'd like to say hi to Dr. DOSWELL. I was actually a meteorology student a couple of years back there at the University of Oklahoma.
Hi.
Didn't have the pleasure of getting his class, though. My question was, if we were going to dissipate the energy in these storms and maybe hold back the tornado from forming, and maybe even in hurricanes too, who's not to say that if we hold that energy back temporarily, one might form even stronger maybe down the road? What's going to happen there? Where's the energy going to go?
Well, my experience is that a tornado is a tiny, tiny piece of the total energy of a storm. And if we disrupt the tornado, as far as the storm is concerned, the tornado appears to be an afterthought, kind of a flea on an elephant's back. Of course, that might not be the case. We're not entirely sure of that. So what Mr. Eastlund is talking about doing with his microwaves is disrupting the storm. And there we begin to get into some really potentially disturbing questions. The thunderstorm itself, if we disrupt it, it's clear thunderstorms have a role in the atmosphere. We think we know more or less what that is. And again, if we start messing around with it, we could have big problems.
There's another problem. Sorry.
This is Dr.
There's another.
Well, let me. All right, let me. Dr. Eastlund, you go first, then we'll go to the next one.
I was just going to comment that the real answer to this question is we don't right now have codes that are good enough to predict this phenomenon. And I hope when we develop them with the proper microphysics, they will be run to see if there are things to worry about. You would be foolish not to look at all the consequences of anything you do here.
Dr. Emanuel?
I was going to say there's something that we haven't really discussed here, which I think is very important and problematic for all weather modification, that even if you could modify a thunderstorm or a hurricane in a way that didn't appreciably change the energetics of the atmosphere, as the caller put it, you have the problem that the atmosphere is a chaotic dynamical system, and any time you make the slightest change to it, any detail of it, the details of that system downstream, the weather, becomes quite different from what it would be otherwise, even if you don't change the climate or the statistics. Now, the problem with that is that supposing we went out and were successful in preventing what would have been a devastating tornado somewhere. Good. We've done that. We haven't changed the climate, let's say. We haven't changed the statistics of the atmosphere. What we have done is change the detailed evolution so that 3 or 4 days later, there's a blizzard on the East Coast. And someone with a model comes along and said, if you hadn't modified that thunderstorm in Oklahoma, we wouldn't have that blizzard. And you know, that's not implausible the way the atmosphere works.
Exactly.
And you're going to get sued. And this is a problem, and it's one of the things that I think that is a real showstopper or potential showstopper for any kind of weather modification.
In fact, when I was in Coral Gables watching many years ago, decades ago, watching these experiments, that was one of the things we talked about with the scientists, was one of the reasons they thought they would have to stop their experiments over, and why they were doing them only in clouds that were over the Atlantic, was that they were afraid that they could generate too much water, being unknown what could happen, and get sued. And being a government agency, there would be a lot of hot water about creating a cloud burst or something unknown at that time.
Let me draw an analogy to show how complicated it is. Supposing that we talk about something quite routine. Supposing I'm a surgeon and I save someone's life on the operating table, and 4 years later that person kills someone. All right? Am I liable? I did something to a chaotic dynamical system, in this case one that involves us, that changed history. in ways that nobody could predict. But somebody might be able to backtrack and hindcast and say, yeah, if you hadn't saved that guy, these people would be alive today. It gets to be very complicated, and I don't think anybody would want to say we shouldn't stop saving people's lives because of this, but we have to proceed very carefully.
I'd like to step in just a second on this. One way you describe this as a scientific issue when you're doing computer modeling is you assess the predictability of what you're doing. And, to guard against chaos issues and things, you rerun your codes to see if they predict the same things. And two scientists at the University of Oklahoma have done this with the ARPS code. And it's very interesting. They found that supercells, big storms, are only mildly sensitive to the initial conditions. Weaker systems vary considerably. So there are some indications that when something is well developed with very strong currents of air, you can predict possibly what it might do. If it's a weak issue or a weak thing, and something in Oklahoma correlating with something in Virginia, it's hard to make those kinds of predictions. But hopefully, for the supercells and for the strong weather systems, the codes may end up being able to do the job.
Sounds like this new field of chaos that
yes,
people talk
Well,
about.
I think that's very closely tied to all of this. I would comment that the simulations that Mr. Eastlund's talking about are still pretty primitive, and in my opinion, which may not be held by every scientist, but certainly is at least representative of a few of us, we believe that, in fact, the numerical simulations of which he speaks are terribly sensitive to the initial conditions. We've done some experiments of our own to suggest that, and some of that has kind of been swept under the rug. So I'd say that that's still an area that needs considerable research.
Dr.
Absolutely.
Sorry, step on your...
I just want to say absolutely.
Okay. Dr. BRUINTJES, you went to Mexico. Didn't the Mexican government invited you down to do cloud seeding experiments there? And did they consider it a success?
Basically, this was a research program. There's been cloud seeding programs ongoing in Mexico for many years. So when they, in 1996, approached us, and then based on the results that were found of the hygroscopic seeding in South Africa, we said we are interested, but we are not interested in an operational program, but basically testing this new principle. And they then provided funding for that. Actually, the funding was provided by a steel mill, a private company, through the government of the state of Coahuila. And this is how we basically conducted the 3-year experiment, initially in the first year to do microphysical measurements, seeing how different the clouds are from the South African clouds, and then conducting the randomized seeding experiment.
We're talking about the weather modification this hour. Talking of the Nation Science Friday from NPR News. Were they judged a success, the experiments? Did you get more water for the area than you might have? Or
we did not get more water. However, the statistical results were so remarkably similar to the South African results in terms of indicating increases in rainfall from seeded clouds as opposed to unseeded clouds. That in itself, I think, is a remarkable result in terms of, if you compare this to previous programs, where oftentimes when programs were attempted to be replicated or confirmed, where the same statistical results were not achieved. So I think that is an important point, and I think an important result for us. The step of increasing water over a large area, that step has not been assessed, and studies need to be taken into account. And coming back to what the other person said also, I think one thing that comes out of this discussion on the tornadoes, the hurricanes also, is that the basic problems in weather modification are very closely related to problems in the effects of clouds, in climate change, and also in forecasting in general.
So do you think that the global warming may have an impact on all of your kinds of research and the importance of it?
It certainly could.
Absolutely.
So this is good, would be better business for you, so to speak, to have global warming.
Well, I think if you sit down and ask yourself what are the effects of global warming on actual weather, that becomes, for reasons that we've already talked about, rather problematical. And this is also an area where there needs to be a lot of research. Does global warming mean more tornadoes or fewer tornadoes? At this stage, I think it would be only speculation to try to make those connections.
So I guess then the biggest obstacle to your research, all of your research, would be finding funding to do it.
That's always the case.
I think maybe if I can jump in here, the problem is that people are doing these kind of things operationally, like rainfall enhancement and hail suppression all over the world. So millions of dollars are spent on these kind of problems.
Yeah.
For either water resources problems or basically severe weather mitigation. I think that also, therefore it is important that some of these things are better studied in terms of developing a better scientific basis for these operational programs.
10 seconds.
I guess I would also point up maybe a bit of an ethical issue. If those things are being done and there is no firm scientific basis for it, then essentially they're being paid to do something that may or may not have the desired result.
All right. We're gonna have to leave it there. We'll come back to it in the future. I'd like to thank all my guests. This hour, Charles DOSWELL, Senior Research Scientist at the Cooperative Institute for Mesoscale Meteorological Studies, University of Oklahoma in Norman. Bernardo Eastlund, President of Eastlund Scientific Enterprises in San Diego. KERRY EMANUE, Professor of Atmospheric Science at MIT. And ROELOF BRUINTJES, Scientist at Mesoscale and Microscale Meteorology at NCAR in Boulder, Colorado. Thank you all for joining us this year.
You're quite welcome.
You're welcome. Have a good weekend.
Accuracy Mike Class 5, planetary at Grid 100.